Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Parity Patrol 101 by Jonesy. And here are the rules. Hello! Hi Jonesy! We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that every row, well actually, let's put it this way. Place the digits, in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. Digits in a cage sum to the number given in its corner, and digits may not repeat within a cage. So, for example, if this were, say, a 7, this would have to be a 4, because these two digits must add up to 11. Oh, okay. So, yeah, that's an example of how these are killer cages, so that's an example of how killer cages work. We also have, in any row or column, no more than 2 consecutive digits may have the same parity. That is, be both odd or both even. For an example, a sequence such as 2, 4, 5, 7 is valid because even though these are both even and these are both odd, they form only 2 consecutive digits of the same parity. You cannot have 3 consecutive. So I guess another way of putting it is that in any row or column, you cannot have 3 consecutive digits of the same parity. Every other sequence is possible, or you can't have 3 or more digits of the same parity be consecutive. I would put it that way probably to make it clear. Because when I first read this, I thought it was basically you can't have any you can only have one set of 2 consecutive digits be the same parity, but I guess that's probably too restricting. So that's, anyways. So 2, 4, 5, 7 is valid because even though these are both even and these are both odd, it's only just 2 each. What you cannot have, 2, 4, 6, 3 is not valid since there are 3 even digits that appear consecutively. So again, I would put it that in any row or column, you cannot have 3 or more consecutive digits have the same parity. I would put it that way. That makes it very clear what exactly it is that you're looking for. Anyways, have fun. We will try. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's look at some obvious stuff. 3 digits adding up to 24 is 7, 8, 9. That means the remaining digits in row 5 are 1 through 6. When you have 2 digits add up to an even number, they must be of the same parity. So this is the same parity. We're going to mark it as green. So this cannot be the same parity. We're going to mark it as pink. Well, 12, to add up to 12, it has to be the same parity also, right? It's either 3, 9, which is both odd, 4, 8, which is both even, 5, 7, which are both odd. So if this cannot be pink, so this also has to be green, which forces this to be pink. And you cannot have 2 greens here because that would be 6 greens in row 2. And 8 must, again, to add up to an even number, you have to have 2 digits of the same parity adding up. So these must both be pink. Okay, so if these are both pink, this cannot be pink because that would be 3 pinks in a row. So this has to be green, which means we know this has to be odd and pink has to be even. So this has to be a 2, 6 pair to add up to 8. This is even. 12. This is odd and even, so that's not helpful there. This cannot be 2, 9, so it could be 3, 8, 4, 7, no 5, 6, because we have a 2, 6 pair here. This has to be 4 or 8. This is 4 or 8. This has to be, okay, so if this were 3 and 5, that would eliminate all possibilities for this 12 cage, because it cannot be 4 and 8. So this has to be a 1, 7 pair. That eliminates 1 and 7 in the rest of the row. This can't be 5, 7, so this is 3, 9, which forces this to be 5. Also, because this is odd, and this is even, this must be 2 evens. Because 17 minus an odd is an even, and therefore these two add up to an even cell. That 4, this must be odd, and this must be odd. And 17 minus 5 is 12. So this has to be a 4-8 pair here. Interesting. What else do we have? This cannot contain 3, 4, 8, or 9. So that means this cannot be 1, 3, 9, obviously. So for 1 as the lowest digit, it has to be 1, 5, and 1, 5, and 7, which would be all odd digits. So that's 3 consecutive odds. So it cannot be 1, 5, 7. So 1 cannot be here. 1 has to be one of these two digits. Because you can't have 1, 3, 9, no 1, 4, 8. 1, 5, 7 was the only other option for 1 as the lowest digit, and that's not possible because that would be 3 odd digits. So it has to be then 2, no 2, 3, 8, no 2, 4, 7. It has to be 2, 5, and 6. So these are both even, which makes this odd. So this is 5. This is a 2, 6 pair here. Because you can't have 3 and 4, and 3 digits adding up to 13 cannot start with a 5 as the lowest digit. Therefore, this is a 1, 7 pair here. Where is 1 in row 1 then? It cannot be here because of the 1, 7 pair. This has to be 2, 5, 6. It cannot be here to add up to 11. So it has to be here. So this is 1, and it's odd. That forces this to be even here, which forces this to be odd to add up to 11, right? To add up to an odd digit, you have to have an odd and an even digit for 2 digits. So this is 4 or 8, and this is 3 or 7 here. This is odd. Where is a 7 in row 1? Cannot be here because of the 1, 7 pairs in the boxes, so this must be 7 here. 7 must go with 4. That forces this to be 3 or 9. These are 2 even, so this must be odd here. These are 2 odd, so this must be even here. This is 2 even, so this must be odd here. To add up to an even digit, it must be an even, and then these must add up to an even. So this must be odd, which forces both of these to be even here. Because you can only have 2 consecutive ones here. This is actually a very interesting rule set. This is a 2 odd, so that forces this to be even here. We know this is 2 odds and 1 even. Okay, and this cannot be 8. So this is because of the 4, 8 pair in the column, so this must be odd. So we have 2 odds here, therefore this is even. Therefore this must add up to an even cell. We don't know if it's 2 evens or 2 odds, so we'll mark it as yellow for now. One of these is even, one of these is odd. We have, okay, this is 2 odd cells, so this must be even. We have 4 evens in box 3, so this must be odd. We have 1 even, 1 odd here. If this was odd, that's 3 odds in a row, so this must be even. Which makes this odd. This is 2 odds in a row, so this can't be odd. That's even, which forces this to be odd. So this is 3 or 9. The only even remaining in row 1 is 8, so this is 8, which makes this 4, which makes that 8, which makes that 4. This leaves this as an 8 in box 3. This is a 3-9 pair. That leaves the remaining odd digit in row 5, 3 as a 5. This is 2 or 6 here. Not sure which. Remaining digits in row 4. 1 even and 2 odd digits. That sums to an even number, right? 2 odds form an even, plus another even makes that an even digit. To add up to an even digit, then it must add up with another even digit. So this is even. If this was even, that would be 3 evens in a row, so this is odd. That's 2 odds here, so that makes that even, which makes this odd. For the remaining digits, this cannot be 1, 3, or 5, obviously. It's 2, 4, or 6. This is 2 odds here, so that must be even there. Okay. We have one of these is guaranteed to be even. This is even here. We have 3 evens in box 5, and then 8. So that's 4 evens, which means the rest are odd. So these are both odd, which means this is even. This must be even here then. Since this is even, these must be either the same set to add up to an even number. So this is going to be an odd amount. Orange and orange. Huh. If this is even here, that would form 3 evens in a row here. So this is odd. Since this is odd, this must be an odd and an even digit to add up to an even sum, right? So this has to be odd and even, which means we have 4 evens in box 6, so this must be odd here. Okay. This is some other color for yellow. Orange, orange. So we have 2 each of green and orange around them. And we have 2 each of lows and highs, which means we have all the, evens and odds. That means we have all the evens because we have 4 evens guaranteed in row 5, so this must be odd. So since this is odd, odd, oranges must be even. So these must be odd. So this is an 8. This cannot be 8. It's 7 or 9. This cannot be 2, 4, or 6. It's 1, 3, 5. No 2, 4, 6. No 1, 3, 5 here. No 1, 3, 5 here. Where is the 8 in row 4? Cannot be here because of the 8's in the column and the box, so this must be 8 here. We have, again, this is odd and even. We don't know which is which. This is 2 odds in a column, so this is even, which forces this to be odd here because we have 4 evens in box 4. Okay, we have 2 odds here, which means this cannot be odd. This is even, so yellows are even now, and pinks are odd. We have 2 odds here, so this must be even. 2 odds here, this must be even. We have 4 evens in column 4. We have 5 odds in column 7. So this has to be odd, and this must be even here. Okay. What else do we have? This is 1 odd, 1 even. This is even. So this must be an odd and an even here. So we know this is odd and even. This is odd and even. That gives us 4 evens in row 8. So the rest must be odd. So this is odd. This is odd. We have 5 odds in column 5. So this must be even here. We have 4 evens in box 8. So this must be odd. So this has to be a 2, 6 pair, which adds up with 4 to add up to 12. So this is 4. Therefore, this can't be 4. Where's the 4 in box 5? It has to be here. This is 2, 6 also. That leaves 8 as this digit here. That means this is 2 or 6 also. Okay. So to add up to 21, it's either 4, 8, 9 or 6, 7, 8. So either way, there's going to be an 8 here. Because you have to have 2 evens here, because this is even. Because of that... Oh, this can't be even, because if this is even, all 3 of these would have to be odd, and we have 3 consecutive odd digits. So this has to be odd, which forces this to be even for 2 evens, or 2 odds in a row. This is 2 odds in a row, so this must be even, which forces both of these to be odd. So to add up to an odd digit, we have an even and odd, therefore this is even here. That's 4 evens in column 9, so this must be odd and odd. We have one blue in row 7, 1 even in row 7, and it cannot be here because if it's here, these are 3 odd digits. So this has to be odd. We have 2 odds here now, so this must be even. To add up to an odd digit, this is odd. We have 4 even digits in column 1, so this is odd. To add up to 24 as an even, odd and odd give you an even number. Even plus even is even, so this must be even here to add up to 24 as an even. So this is even. We have 4 evens in column 3, so this must be odd, which forces this to be an even here. And we have 5 odds in box 7, so this must be even. Oh yeah, okay, so those are both even anyways. Okay. This has to be 2 or 6. So then now it's just adding up the sums and figuring out what can be what. This is 2. Can it ever be 2? 2 with 3 and 5 at most adds up to 10. So no. So this is 6 or 8 here. If it's 6, it has to be 1, 5. If it's 8, it has to be 1, 3. So either way, there's a 1 here. So this cannot be 1, 3, or 5. These 3 add up to 12. That's interesting. This cannot... This is... So one of these is 8 guaranteed. 8 cannot be here, so 8 has to be here. So this is 4, 6. So this is 21 minus 8 is 13. So it's either 4, 9 or 6, 7. This to add up to 9 here cannot be 1, 8. Could be 2, 7, 3, 6, or 4, 5. Okay. This is 8. Where's the 5 in box 5? Cannot be here, can't be here, so it's one of these two. So this is a 5. This is 2, 4, or 6 also. 18. If this is 2, this has to be 7, 9. If it's 6, it's either 3, 9 or 5, 7 to add up to 12. So those are the possibilities. 20. Okay. This cannot be... The remaining digits in box 5 that are odd are 1, 3, 5. This is 1 or 3. Interesting. Remaining digits in row 4 are 1, 3, it can be 1, 3, 5, 7, 9. No 1, 5 here. 1, 3, 5, 7, 9. No 7 there. So it cannot, okay. These 3 digits add up to 12. So can you ever not have 1? 3, 5, and 4 works. Yes, so that could be the case. Okay. So we filled out that cage possibility. We filled out that. We filled this out. This also. So 1, 9, 1, 9, 2, 1, 7, 4. Oh, interesting. This, well, it could be 1, 9 if this is 5, 7. Huh. 24 cage. That's the only one we haven't filled out. That's 16, which is pretty broad. This can't be 4, 8, so it's 2 or 6. Ah, okay. We have a 2, 6 pair in column 3, which eliminates 2 and 6 in the rest of the column, so this can't be 6, this is 8, which forces this to be a 1, 3 pair. So this is 1, 3, which eliminates 3 in the rest of the box and the column. So this can't be 3, this is 5. So 5 cannot be here. Where is the 5 in row 4? It has to be here. So it cannot be 5, 9, and 2, or 5. It has to be 5, 7, and 6. So this is 6, this is 2. 6 eliminates 6 here, so it's 2. This can't be 2 and 7 anymore. This 5, 7 pair eliminates 5 and 7 here. Either this is 3, 9, or 1, 9. And 3, 9 does not add up to, already adds up to 20 without another digit, so that's not possible. So this is 1, 9. So we have 1, 9, 1, 8, 9, and 2 add up to 20. So that's 2. This can't be 2. This is a 4, 6 pair, which eliminates 4 and 6 in the rest of the column. This can't be 6, so it's 2, which makes that 6. That leaves this digit as a 2, which eliminates 2 here, so it's 6 and 2 there. This is 2, 4, and 6, so this is 8. We have a 4, 6 pair. This 6 eliminates 6 here, so it's 2, which makes this 6, which makes that 2, which makes this a 6. So that's not a 6, that's a 2. No 2 here. This is 4, 6, 4, 6, 4 or 6. Okay. This 1 eliminates 1 here, so this is 3. This becomes a 1, 5 pair. This is 2 and 8 added together. So the remaining digits add up to 24 minus 10, which is 14. So it has to be 5 and 9. Where is, so the remaining digit in box 4 is a 9. So this is 9, and this is 3 or 7. So in column 1, where is the 3? It has to be one of these two. So this cannot be 3 here. So this is 5 and 4, which makes this 6, 7, 8, adding up to 21. 5 eliminates 5 here, so it's 9 and 5. 5 eliminates 5 here, so it's 1 and 5. 4 eliminates 4 here, so it's 6, 4, 6, 4, 6. This 6 eliminates 6 here, so it's 4. We have all the even digits. 1 eliminates 1 here, so it's 7 and 1. Okay. Again, we have 1, 3, or 7 here, 1, 3, or 7. 7 eliminates 7 here. It's 3 and 7. 3 eliminates 3 here, so it's 9 and 3. That leaves this digit as a 3, so this cannot be 3 here. We have a 1, 7 pair in column 1. That eliminates 1 and 7 in the rest of the column, so this is 3. That's 3 in the corner. We celebrate because we know we're close to solving this. We have 1 remaining in column 8. We have 5 and 9 remaining in column 9. This can't be 5 because of 5 in the row, so this is 9. That's 5. That leaves 7 remaining in row 9. 7 eliminates 7 here, so it's 9 and 7. That leaves 1 remaining in column 6. In row 8, it's 3. 3 eliminates 3 here, so it's 9 and 3. That leaves 9 in column 4. 5 eliminates 5 here, so it's 7 and 5. 9 eliminates 9 here, so it's 3 and 9. 3 eliminates 3 here, so it's 1 and 3. That leaves this digit as a 7, which means this can't be 7. That's 1, which leaves that as 7 and 1. Thanks for playing. Thanks for setting. This was really cool, actually. This rule set was very interesting about having no more. You cannot have 3 or more consecutive digits of the same parity. And it's a very cool, fun coloring exercise, too. So overall, very nicely done. Nice puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.